In problem number 13, we're given that quadrilateral ABCD is a parallelogram with diagonals AC and BD intersecting at E. That's all the given that we have to prove that two triangles AED and CEB are congruent to each other. So I actually like to start with these problems just by highlighting over the triangles, since there are so many in this diagram that I could be looking at. So I know I want to prove that this triangle AED here, and BEC are congruent to each other. And now that these are highlighted, I'm already seeing certain things that I could add into my diagram before I even delve into the givens. So for instance, I can see vertical angles are congruent to each other. That gets me an angle pair. That's kind of all I'm really seeing right now, so I have to use this detail about the fact that I know I have a parallelogram to help me sort some more things out. So now you kind of have to think about other things that happen in other units than just congruent triangles. We have to remember facts about quadrilaterals to help us answer certain proofs. So what I know about parallelograms is a couple of things. One thing that I know for sure is that opposite sides are congruent to each other. So that gets me a pair of sides congruent. Something else I know that might help: diagonals bisect each other. I could make this an SAS proof. I could say that opposite sides are parallel. That can make that another type of proof. So there's a lot of ways you could take this proof. The way I'll show you is by using more properties of parallelograms. So I'll say that AD, they're not just congruent to each other, they're also parallel to each other. So if they're parallel to each other, then I know that alternate interior angles are congruent. So that gets me this angle here at D, congruent to this angle up here at B. So that gets me two angles and a side. This looks like my plan is going to be an AAS proof. And again, it doesn't have to be. If you're noticing different things, different relationships about a parallelogram, that's awesome, and go with it. Just make sure your teacher reads it. Make sure you have all the details necessary. So now I'm ready to start writing this proof. I set up my statements. I'll set up my reasons. And in the first line, of course, always goes our givens. So a lot of people ask, can I just write like ABCD as a parallelogram? You don't want to cut corners on the givens. You want to make sure you're getting your full credit for being as thorough as you can be. So in step one, I'll say I have quadrilateral ABCD is a parallelogram with diagonals AC and BD intersecting at E. All given. In step two, this is when I want to start chipping away. So a good rule of thumb is anything that I mark, I should be writing. So the first thing I marked was the vertical angle. So I can say angle AED is congruent to angle CEB by your vertical angle theorem. Next, I hit the properties of a parallelogram. One got me a side, one got me a relationship. I'll put them all in the same step because it's going to be the same reason. So AD is congruent to BC, but also AD is parallel to BC. Both properties of a parallelogram. The next thing I marked from there were my alternate interior angles. So that's that angle D at the bottom and B, but I'm not going to write D and B out again. I'm going to use three letters like I did for my vertical angles. Again, you want to be as thorough as possible when you're doing these types of proofs. So angle ADE is congruent to angle CBE. That's my alternate interior angle theorem. So now if I look at the list, the rundown of everything that I've stated in my proof, I have my pair of angles from step 2. I have my side stated from step 3. So I got an angle, a side, and in step 4 I stated my last pair of angles that are congruent to each other. So I fulfilled my plan, which is in step 5 to show that triangle AED is congruent to triangle CEB by AAS. And now my proof is all set. Remember, there were a couple ways you could do this one, so I encourage you watch this video again if you'd like, or show your done proof to your teacher if something triggered your memory to think about parallelograms a little bit differently.